Okay, so class, we will continue where we left off right over here. I kind of went to this one really quick, but if you have a normal curve with a whole bunch of data points inside it, we have this little interesting concept of, we talked about standard deviation, is that right? Did we talk about that? Maybe. Some people say yes, some people say no. Yeah, we did, right? There was the Greek letter for S, right? And we had to take the square root of variance, which was just the square of it, right? Talk to me, making sure. Does that make sense? Some people are like, whoa, what happened on Tuesday? Okay. All right, so about 70% of the data, if we take one standard deviation this way, one standard deviation this way, it's about 34% of the data, but we could say 68. 68% of the data lies within one standard deviation. If it is a nice, we call it a bell-shaped curve. We're good. Now, you know how we drew those bar graphs, right? Those are just a few set of data. Now we're talking about a whole bunch of data, right? And what we've done is, instead of doing individual points, we've kind of made it continuous now, right? So it's a little continuous feature. Okay, 2 standard deviations. We pretty much have everybody at that point. It's 95%. If you're 2 standard deviations away, you have 95% of the data points right over here. And then if you go out 3 standard deviations, forget it. Really, you're just missing 0.3. So if you want to write it down as a, oh, sorry. If you want to write it down as in that, that's fine. If you just want to put it in. As you guys are doing that, let me take a roll. Thank you. Okay, let's go back to like this. Let's go back to the formulas themselves. So I'm going to go back to here just to connect. Let's connect pieces here. So if you have a population, we have, oh, not, that's already the worked out formula. I don't want that one. I want the formula itself, which is this right here. So we have these 2 things. We're trying to figure out how much spread you have in your data. That's the whole question here. Yeah. So we have population variance, and then we said, you know what we can do is we can just get standard deviation and we're good to go. So now the question is, what's so special about standard deviation? And so as we look at the data, we keep on, so this is not so much as like, oh, this is worked out. It's looking at thousands of pieces of data, different surveys. We find this interesting concept that the standard deviation does mean something very standardized to data. And what it means is any kind of data you have, as long as it fits into this nice bell-shaped curve, as long as the curve looks like this, right? You will always have, if you go out 1 standard deviation, you get 68% of data. I was actually listening to a talk about aggression in males versus aggression in females. It's a nice bell-shaped curve. It's across the population. It's worldwide. I mean, they've took samples of different, right? They have to fill out a survey of aggression survey. It's just like this. It's a nice bell-shaped curve. In the middle is whatever the point score is on the test itself, right? And you have a certain amount of people above it, a certain amount of people below it. So then if we were to take this formula, which is what we just did, right? The little formula of standard deviation, and we take it across, we find out it's 34% going one way, 34 the other. Does that help, Tristan? Does that make sense?
Yeah, no, I don't stop.
Yeah. So it's across different ones. So all these different people that have, when they started statistics as a branch of mathematics, and let's say 4 people started it, right? 4 people did surveys and they come back like, hey, this standard deviation thing, it's the same. It's consistent throughout all the stuff we do all the time. And so it's always 68%. Or it's always 95% as soon as you go out 2. Does that answer your question, Tristan? Does that make sense? Yeah. And we'll figure out a little trick to make almost all things this nice bell-shaped curve. There's a little trick to it most of the time. So that's why this becomes very, very important right here. Okay, let's jam this. So this is, we've got 2 just so we know. We have population variance, right? Population standard deviation. Talk to me. What else do we have? Thank you. Yeah, we have the population one, which we did not work out last time, but there's also a one for sample, which is this little guy right here. Everybody wrote it down last time, I believe. We did not do a computation to it, but at least we wrote it down. So sample variance, sample deviation, talk to me. What is the difference between the two?
Oh, the negative.
Yeah, for the sample, and we're going to divide not by how many there are, but how many there are minus one, just to give a little bit. And this is that little piece there. Population, 68%, one deviation. And then when they start playing with this, because eventually math is about play. When they start playing with the numbers for samples, it did not work out that way. So how do we adjust that so that we get that 68%? And so, oh, for sample, that's what we got to do. We just have to take one less, and we got ourselves what we need. Okay, you guys talk to me here. Do we need to do a computation with sample, or are we okay? Like thumbs up for yes, let's do it. And now thumbs down for no, we don't need to do it. Let's go on. Oof, oh, sorry guys. 6-2. Majority rules here. So let's jam with one here. Remember the computation is like a lot, right? So there it is. Study high school football players that suffered concussions. Oh no. Research players, 2 groups. Players that recovered from concussions in 14 days or less. Those that took more than 14 days. So there's 2 different groups here. The recovery times just for group 1. We're just going to do group 1. Is listed. Find the sample variance and the sample standard deviation of the recovery times. All right, let you guys try it, right? Because we have to put it into columns, right? First column is just the data. Second column is something about taking out, subtracting from the average. Is that right? So take a look at your notes. Go for it. Lots of formulas in 2.4, lots of formulas, lots of things to keep. And so I forgot to cover this one up. Okay, so this is what I got. Is that true? Just don't copy the numbers. I don't want you guys to do that. I want you guys to sort of look up when you get stuck. I'm like, oh yeah, that's right. And then keep on going. We're good with your data. So first column is just the times themselves, 4 all the way down to 10. We do need to get the average for this. So you have to add them up, divide by 6, 7, 8, 9, 10, 11, 12, divide by 12. Second column is going to be the subtraction from the average. Or subtraction by the average. And then the second one's going to be the square of it. I should have. try to get the same numbers that are here. I'm going to pause here. Let me walk around as well. Help if you need help. All right, class, let me jump to this here. So if we should have something that looks like this and that, and I think the 11 has been explained. Is that right? As a class, because let's take a look at standard deviation as a graph and in terms of just numbers. You should be able to sort of like, oh, yeah, it's gonna be this much, or it's approximately this much. Let's go with it. Dun, da, da, da. And I'm gonna go with this one first. Dun, da, da, da. I have n, there's n number of things here. The average is 4. What's my standard deviation? Of course, the answer is there. Is there any variation? No. All the numbers are exactly the same. All 4 of them are 4. So the standard deviation is 0. There is no standard deviation. We're good? Not a single data point was different from another one. Okay, are we good there? Next one. I got this one. So I have 8 people took a test. The average is 4. This is a population. The average is 4, but then exactly half of them scored a 3. Exactly half of them scored a 5. Standard deviation, it's going to be 1 because, like, if you just move out 1, you're going to get all your data points, right? We're going to get 70 for sure. We're going to get 70, right? But we're going to get a whole bunch more as well, right? And again, that does not normally happen. And let's look at uniform now. Let's look something like this here. So again, 8 people, 2 of them scored a 1, 2 of them scored a 3, 2 of them scored a 5, 2 of them scored a 7. And so now the question is this. All 8 entries. Oh, this is a good one here now. Let's see. So half of them, 50% scored between 3 and 5. True? Everybody agree? So then my standard deviation, again, I have to get to 68%, right? So that means my standard deviation is going to be a little bit bigger than 2, if that makes sense, right? I'm not going to get all the way to the, if I include the 7 and the 1, I'm going to get to 100%, right? But 1 standard deviation is going to give me, it's kind of like, where do you get that 70%? So where's your 70% of this data? Well, 50 is right here. This will be 100. And I'm only going out 1, right? 1 or 2, right? So that means it's going to be like right here. So it's going to be like 1, 2, and then a little bit more, or roughly 2-ish, right? Or a little bit past 2. Okay. I'm not sure if that helped or not. Does that help? Just trying to imagine with small numbers, trying to get to that 68% marker of it. A little tiny bit. Okay, let's jam to, let's work a little bit more with the standard deviation stuff. Let's go to here. Don't need to write it down. Let's kind of think with our heads here. Ready? So survey conducted. Survey means sample. All right, survey. If you do a survey, you got yourself a sample. Oh, let's see. If you surveyed every single person, then you got yourself a population, right? If you surveyed only a few, usually surveys are so small. Okay, National Survey of Health. This is the height of women in the United States, ages 20 to 29, was 64.2 inches. We have a standard deviation of 2.8 inches. Now, women in the room, you guys get to decide where you fall now, okay? If you know your height. And so here it is, estimate the percent of women whose heights are 58.4 inches and 64. Why all that stuff? Let's make a little curve of stuff. So if you're at 64.2, and if you add 2.9 to it, you're going to get something that looks like this. So the only thing that we're thinking about is that women in the, is it the US? Yeah, women in the US are, here's the middle and kind of half fall this way and half fall this way, right? So notice these little things right here. Oh, this is even more precise. Remember how I said 34%? It's actually 34.13. Just so you know. So how precise do you want the numbers? It depends, right? Okay, so here it is. 64.2 is here. If I add 2.9, we get to 67.1. We add another 2.9, we get to 70. Add another 2.9, we get to over here. So there's 3 standard deviations away. And 3 standard deviations this way. Question is this. Estimate the number of women in America, in the US, whose height are between 58.4 and 64.2. Just kind of what percent of women are fall into that category? Well, 58.4 is the lowest one. 64.2 is the middle, right? So inside this little piece right here, we have 34% here. So let's draw this out. It's an easy way. See if we can just kind of follow along, okay, as we do it. So I know that this chunk here, this is going to be 34%. I know this chunk here is going to be 34%. If you want to get more precise, you can get more precise. One standard deviation, 68%, right? Boom, give me 2 standard deviations. How much does that give us? How much does 2 standard deviations away give us? Oh, I heard 95, yes, so 95%. So if I go out to here, all the way up to here, all the way up to 70, this covers 95%. Everybody agreed so far? So talk to me now. If I have 95% here, and that's 68%, how much is right here and right here? That's what I need to know. So if that's 34, that's 34. That makes 68%. So I'm going to go with 95%. Yes, minus 16 gives me about 13%. Hold on. No, sorry. Let me go back over here. Math teacher can't subtract. That's great. 15 minus, that's 7, and that's 2. Is that right? 27? Everybody good there? So in this area here and in this area here, just from here, there's 27 pieces here, or percent. Let's break that up a little further. So take half of that, that means 13.5% fall here, 13.5% fall here. Everybody's still following along. So this is 34% here, 34% here. That's cool. Let's do one more. If here to here, how much is it if 3 standard deviations to the left and the right? I love it. Everybody okay with 99.7? We already have 95%. So the remaining little pieces here and here have how much? Thank you. Sorry. I still can't do math. All right. What is that? 2.7, right? 4.7. Okay, 4.7. That's on these little pieces right here. That's both of them. Divide this by 2. See again? 2.35. Okay, if we want to get really, really close, because there's. So, okay, guys, real quick here. In here, 2.35%. 2.35% falls here. Are we good? We kind of broke up that the 68 and then the 95 and the 99.7 broke it up now into individual pieces inside. So ask a question. I'm going to ask you guys a question here. So what percent of US women, their height would be 70 inches to 72.9 inches? What's the percent of women that would be that tall? And that means they're 6 foot to 6'2". So how many women go from 6 to 6'2"? And this side of the room, we're gonna have competition. What do you guys say? So I want to know the percent of women. Tristan, 2%. You guys agree with 2%? Yeah, about there. So 6 feet tall. Actually, no, it's right above 6 feet tall. Not quite 72%, 72 inches over 6 feet tall. So between 70 inches and 72.9 inches, about 2%. Or 2.35 if you want to be precise. Okay, we good? All right. I want to know this. What the percent of US women are 58.4 inches tall or less? This side of the room. What percent of US women are 58.4 inches tall or less? Also 2.35. Are we good? We're going to say roughly 2%. Going to say roughly 2%. Depends on the homework, how precise you need. So let's do this now. So this guy is 2%. This guy's 13.5. We'll leave the 5. And this is 34. That's kind of what we're looking at. Same thing on this side, 34, 13.5, and let's say 2%. Okay, real quick here. Back to this side of the room. Number of women in the US that are 67.1 inches tall or taller. Percent of women that are 67.1 inches tall or taller. About 15%. Everybody agreed? It's the 13.5 plus the other 2, right? That's what we're looking at. We're looking for that. Okay, are we good? Is everybody seen how we read that chart? On the homework, they make it more precise or something like that, but just kind of, that's still the same process. So you're looking at individual pieces. Okay. Then let's jam to one more thing before break. Let's go to this guy. Oh, 2 more things. Okay. Should be highlighted. And let's do just one quick data. This one should be highlighted. Let me go back up to highlighting it. We have a Russian statistician. He decided to figure out what's the lowest possible percentage you can have inside that little empirical formula, right? If you go 1 standard deviation away this way, you get 68% normally. But his question was, what's the minimum that could ever happen? So if you go 1 standard deviation away, the minimum, no matter what data you use, you're going to have at least 75% if you go 2 standard deviations away. That's minimum. We good there? So instead of 68%, sorry, 95%, right? The 2 standard deviations. Let's see if that's right. Yeah. Here's the middle. Normally, if this is very nice data, you're going to have this. 1 standard deviation away from the middle is going to give you 68%. That's normal. 2 standard deviations away is going to give you 95%. 3 is going to give you 99.7. So according to this rule here, right? He said, what happens if the data is just all messed up? It could be uniform. It does not have to be this bell-shaped curve. What about if the data is like that? That's crazy. Standard deviation still plays a part in this process. Standard deviation will still give you information. So if you find the middle, no matter what data you use, and you go out 2 standard deviations away each way, like this, you're going to have at least, for sure, at least 75% of the data is going to be there. Does that make sense? No matter which way the data looks. If you got 3 standard deviations away, you're going to get 88.9% of the data, no matter which way the data looks. So this works for bell-shaped curves. And so now the question is this: when we get to Georgia, does this look like a bell-shaped curve? No, because it's not like only a few people are born right? Then there's the middle, and then there's a few people that die, right? No, there's usually a lot more people that are younger, right? And then you progressively die as you get older, right? It's true, yeah, Okay, so is this a bell-shaped curve? No, So that formula of the 68, the 95, and 99.7 is not gonna apply here whatsoever. So Russian statistician says, if I find the middle, which is 37.3, and I go out 2 standard deviations away, right here, I know for sure that's still going to give me at least 75% of the data, no matter what the data looks like. And so we plug it in. We plug a k is equal to 2 into our formula. And the formula we want to use is, if the middle's here, I'm going to go away 2 standard deviations. If the middle's here, I'm going to add the 2 standard deviations up. And you get yourself at least 75% of the people in Georgia are between these 2 ages right here. And it doesn't matter how the information looks. Oh, this guy, it's mu, it's the average for the population. This is population. Population mean, that's what that is. For the sample mean, what's the notation we use for sample mean? Da 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 da. What's the exact, yeah, what's the middle or the average for a sample mean? What's the notation? This guy's for population. See it? Yes, so this guy here, you see this guy's sample. We just been doing that. There's your sample mean, which means it was a sample of population, not the population itself. So this data here has to be population because someone went and looked at, I don't know, probably during census or something like that, and then they got the information. Okay, Euphoria, is that okay? Does that make sense? Yeah, okay, DNA. Okay. When you calculate this, when you go 2 standard deviations away from 37 years, and if you go 22 years this way and another 22 years, roughly, you're going to be the negatives because you're 44 years away from 37. So now you get yourself negatives.
So that's why you started, that's why you did it, like adding on the bottom.
So I had to go this way first. There's my subtraction because I want to go this way to see where that's at, right? Then I want to go like, what's the lowest age if I'm 2 standard deviations away? Then I'm going to go, what's the highest age if you're 2 standard deviations away? And that, if you go 22 years here, another 22 years here, gets yourself right at 81.9, almost 82. Okay, everyone, are we good? Okay, not done yet. I'm going to leave you guys to contemplate that for a bit, okay? Standard deviation, okay. Remember group data? Remember that good stuff here? Remember the frequency stuff that we had? Oh man, there's that. There is. All right, so we started all the way back in 2.1. Remember frequency distributions, how often something occurs? The question is, how do we get a standard deviation for that guy? Ryan, question?
Oh, I just wanted to know how to
So this is square root of, and this guy, we don't say sigma, we just say summation. It's a summation of the deviation. Remember, x minus x bar is deviation, right? How much squared times frequency. All over n minus 1. I know, heavy in the math, huh, today. And I got this feeling we're going to slow down as well. Let's do this here with that. Let's take our break now. And today we'll just finish up 2.4. Because I would rather you guys understand it than not understand it. So anybody tired of formulas yet? First of all, raise your hand. Yep. No. Okay. Some people are just, okay. Yes. Yeah. From the people that voted, which was only 4 people, 2 were yes and 2 were no. So it's a split in there. Hey, that's a sample of the class, I think, right? Okay. Frequency distribution. How come we would prefer things in a frequency? Is because you don't have to write down, oh, we did that before, right? Remember that? How we didn't do it in frequency. We had a whole bunch of stuff, but if you do it in frequency, you can condense the data down a little bit here, right? So frequencies are good. Frequency distributions are easy, manageable data. Is that one good or no? So let's jam. Here's what we got. We have we have a collection random sample of children per household in a certain region. Here it is, looking at 50 households. Whoa, I'm going to try to figure out the sample mean. What's the average? And then give me the sample standard deviation of these guys. So how many? Whew, no fun. 6. Let's go with, what's the highest number of children in a family that you know of personally? Let's do that real quick here. Anybody know a family that has at least 7 kids? Okay, 2 people. At least 9 kids. 10 kids. 11 kids. 10 kids. Go back down. 10 kids. Okay, cool. My wife comes from a family of 10 kids as well. So yeah, absolutely. Okay, let's go with it. Can you guys draw this in a frequency distribution? So the lowest is 0, the highest is 6, way better than having 50 points. So we're good? So let's jam, let's draw this, and let's find eventually the sample mean. So I got myself, this guy doesn't work. There it is, okay. Let's jam. I'm gonna put this down, then write it as a column like we normally would, right? And eventually we're gonna do it. So, X here, we know we're gonna extend it out. So we have families that are at 0, at 1, 2, 3, 4, 5, 6. And then you guys do the, no, I should do the frequency. I'll let you guys do the frequency. We can do the frequency towards the end, but we should just write down the frequency already. And then we'll build this up. Okay, once you write that down, I'm gonna go back and give you guys the data. You guys fill in the data, and then we'll see what we would match each other. Okay, good. Everybody wrote down at least that. Let me go back up. There's your data. Go for it. After you finish your data, remember you can do tally marks as well, right? Or you can just count how many zeros are there. Just count how many zeros, go back, count how many ones, and then check with your neighbor. How do you double check yourself if you did it right? All right. How do you check yourself if you did it right? You can do it again. I suggest not. Take it, Devin. Yeah, when you add up the frequencies, they better add up to 50 again, right? That means you got all of them, right? So go, all yours, go. Give me the stuff in the F column. We started the X column already. With the F column. Ooh, that's so very nice. You guys, if you guys can do this little guy here, that would be awesome. I could put down the 25 questions here, and then the 3 questions that we're going to do. Like the first answer thing here, open up second and third. And I can grade them really well. Still back. They're still back in case I have a 4th question. Sometimes we'll have 4 questions, 8. So we'll have that. Okay, good. So this is the scan run. If you guys can grab. Sorry, I took it, grab it. Sorry. Okay, count how many zeros and go. Number of the scan. 886-E. And we're just good in the library. The library has them. 886-E. All right, that's cool. I see some people do telemarks as they go down. That's cool. I see some people just counting up the zeros and counting up the ones, and they put it on the side. They put it on the side. That's cool. And I'm sure they're going to add it to 50 just to make sure they're correct because they're using a pen. And then they're going to bring it over to the table. That's cool too. All right, how many zeros did we get in this? 10 zeros. Okay, that's cool. That's the only answer we did. The rest, yes. Almost done. Okay, how many ones? 19. How many twos? 6. Ooh, 6 or 7. Which one? I got 7. It's going to win out. Okay. How many threes? 7. Already with the 7. How many 4s? Ooh. Okay, nice down real quick. I guess after having a 3rd child, like, nope, no more. Okay, 5. 1 and 6. 4. Okay. Cool. Got that one. Let me write it down. So if you we got 10, 19, 7, 7, 2, 1, 4. Perfect. Okay. Oh boy, here we go. Next column over is going to be x minus x bar. And we can actually just do a sum right over here, huh? We can add things together if need be. Okie dokie. Oh, you know what? Sorry. Can I back up just a little bit? Those with pins, totally sorry for that. Because we have to calculate the average, right? Sorry. Carla, super sorry. Because she has a pin. She's like, what do I do now, Mr. Hengiev? Thanks for messing it up for me. Okay, you guys talk to me. How do we get the average of a group data? Add the who? Hold on, if we have like a whole bunch of numbers by themselves, right? We can add them up and divide by how many there are. There's 50. But if you have already a group data, it's a lot easier to do. What do? I'm trying to get the average number of kids in a household here. What do? We have one of 2 choices. we can go back to here. We can count 1 plus 3 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 1. We could do that. Not very nice. What's the faster way to do it? Multiply. Multiply what and what? Yeah, it's just x times f. Is that right? These two together. Multiplication happens here. This is 10. Just kidding, it's 0. Because once you multiply numbers, right, you get all your, it's just a faster way to add, right? That's all. That's why multiplication happens in the first place. Okay, 19. Anybody give me the next numbers?
14,
Yep,
21,
yep,
8,
yep,
5,
yep.
24.
Okay, that's what you add up. That would be the sum of all these numbers. $91. Can I get a second for 91? Got a second? Cool. Okay, got a 91. Okay, now, funny thing is, these are all summations, right? So if you want to kind of label it, that's fine. You can go summation of x of x is equal to 91. What are we going to divide by? Say again? Yeah, what do we divide by to get the average? How much, Carla? No. No. How much, Brian? 50. We have 50 data points, don't we, over here? Where is the 50 coming from? Oh, it's this guy here, huh? It's the summation of our frequencies. There's my 50. So then my x bar is 91 over 50. Second? 1.82. Okay. So the average household in the US has 1.82 kids. True or false? You can't have 1.8 kids unless you what, chop off an arm here and then a little bit of a toe. So that doesn't make sense. Okay, so now let's keep on going though. Tristan, are you okay still? Cool. Next one is now we go with x minus x bar. And I'm not sure if we need to add that one. I don't think, do we need to add this one or no? We'll see. That's kind of cool. Do you guys see also on the top, you get the formulas, right? So then you know what the formula is. Okay, with your calculator, can you do that there? So this is kind of cool. So we're not getting the averages. Guys, if you guys think about this here real quick, we're not getting the averages per data, right? We're getting the averages for a whole bunch of data at once, right? Because that multiplier in frequency. So we're able to sort of get that in. But for these two, this is just going to be this, right? Subtracting off of 1.82 to get us here. We're not dealing with the frequency thing right now, right? We're just trying to get that column there. So go all the way back to the first column. So 0 minus 1.82 gives me negative 1.82. 1 minus 1.82 gives me negative 0.82. Everybody still okay there? 2 minus 1.8.2. Now I need help on that one. Okay, cool. So 0.18. Perfect. And I think the rest are going to be so easy. This is going to be 1.18, 2.18, 3.18, and 4.18. Cool. Anybody tell me what's the next thing we do? No, we don't add them up. We square them. That's right. So we make an extra column here real quick here. This is going to be x minus x bar, or the deviation being squared. Now I do need help with that because I can't square 1.82 in my head. 31. Let's go, because we're squaring decimals, let's go one more decimal place, maybe, just to give us more accuracy. 312, okay. Just to give us a little more accuracy when we add them up. Okay. I'm gonna let me pick on people here. Tristan, can you square 0.28 for me? Andy, can you square 0.18? .078. Yeah, 0.078. We are squaring each one of these right here, just from one column to the next. Sure. I'll erase. Can you square? Yeah, can you square for me 0.8? Oh, sorry, 0.82. How about that? That'll be so much better. 0.6724, so 2. Good there. Andy? .032. Okay, sounds good. Hugo, he's jamming. Hugo, do you have a 1.18 to the second power? Okay. 1.39. Sorry, 39 what? 2. Thank you. And Jimena? 2.18. 4.75 what? One more after that. 2. Okay. Thank you guys so much. Okay. Adriana, all yours. .24, so 2. And Carla. .20. I don't think so, because 4 times 4 is 16. It's going to be like 17-ish or 18-ish. 472 is perfect. Okay, now this is the one that we add, right? And this one's a little different. It's like this. It's SS, right? It's the sum of the squares. All right, anybody real quick here, add those up real quick. Okay. I'm going to put blah, blah, blah on here. No, let's have this conversation, guys, real quick. Class, if this was just data by itself, I would add those up. Let's look at our formula again. Real quick here. So what, Mr. Hajiev? That's not cool, man. What are we trying to add? Right here, we're trying to sum, right? And it's kind of written kind of nice, not so very nice. We're trying to sum this times the frequency. So let's see if this makes sense to us, guys, real quick here as we talk about it. These are frequencies, right? If you were to add up right here, that means you're saying that the 0 only occurs once and the 1 only occurs once. We're good? But that's not what happened. There were 10 households that had 0 kids. There was 19 households that don't have one kid. So we have to take into account that there's multiple times this zero is going to occur, right? There's multiple times the one is going to occur. How many times is the one going to occur? 19 times, right? Okay, so real quick here, we don't want this one. We want x minus x bar squared times f. And that's the one we want to add here. Yeah, so this little f multiplies this guy, sorry. Yeah, this little f multiplies here to get here, right? Because we're trying to say that's the deviation for that group 10 times over. Yeah, so this one not needed. My mistake. I was going to say I did it on purpose. I didn't. It was my mistake. Okay, now I need 3.312 times 10. That's what I need. All right, let's use 0.627 times 19. 12.7768.
Yeah.
Okay. 7. 8. Okay. Let's see this one. I think I can do this multiple. No, I can't. All right. Let me see. I bugged one side of the room, so let's start bugging the other side of the room. So BNA, can you give me this one here times 7? Totally okay. So 0.224. Okay, sounds good. Euphoria, this one, Brian, this one, Jacqueline, this one, and then Giselle, this one. This in order, so Euphoria. Say again? Jacqueline, do you have yours or no? Or Giselle, if you have yours, you can say it. Oh yeah, that's easy. You got the easy one. Okay, Giselle, if you have yours, you can say it, or Brian, or Euphoria.
30.
I think too high for some reason. Unless you add him, you didn't add him up, right? No. Giselle is doing that one. Euphoria, you're doing let's see, 1.392 times 7. You're doing this one right here. 1.392 times 7. It's the fourth one down. Giselle, you have yours? $9.88. Like that? 8, another 8. Okay, 888. Okay. Sorry, 7 what? 744. Okay, cool. Brian? 504. Okay, coolio. Add them up. And anybody got the addition yet? We add those guys up. There's a lot of tedious work, isn't it? Like this one multiplying this one again and again and again. Part of it is I do want to know where, for you guys to know where the numbers are coming from. That's what we did. It's not a mystery. It's just like, oh, that number comes from here. Okay. You could probably even like do it like this right here. It's the summation of squares. Summation of the squares times f. I guess you can write it like that. So yeah, please. 0.202, 140.202. Anybody verify that real quickly here? 1.536, 1.5, 145.36. Okay, first check those if you want to do again, just real quick. Okay, since I'm going to go with the majority of the group here, so then we have ourselves finally the standard deviation of the sample, because of group data, is the square root of 145.36, all divided by what number? It's a sample standard deviation. Let's see, how many points do we have? How many households did we look at? 50, so it's a choice between 50 and 49. Which one is it? Ooh, half the class at 50, half the class at 49. They would take a data of all the households in America, or do we take a sample? Sample. So this is a sample standard deviation. What do we do because of sample standard deviation? Subtract 1, right? Because of sample error, right? We're still trying to get to the population, but we're accounting for that. We don't have all the information. 49. Okay, all yours. And if you want to, you can probably go like this. Give this little wavy equal sign, approximately. Say if we're a little louder. I need an answer. 1 point. Yeah, I'm gonna go like 1.7 because our average was 1.8, right? Oh, hold on. Let's see. Our average was what, 1.82. And this is the funny thing is, guys, real quick here, how precise do you need it is based upon what you're doing. We good? So if you are kind of like, I'd say if you're close to the answer in the back of the book, most likely you did it correctly. We're good. If you wanted to just kind of jump to the back of the book to see if they moved to the 10th place or the 100th place or 1000th place, you can do that, right? But if you're kind of close, like, yeah, I'm doing it correctly. If you're way off, then like, man, what's going on? So, Hugo, 1.7 what? 22, so 1.72. Since this guy is to the nearest 100th, I'll make this guy to the nearest 100th. Okay. So assuming that these are actually numbers for a population, right? This is the number, the average is 1.8, population is this. And assuming that now I'll stop there. We won't go there. Okay, guys, one more. That was the easy one. So this one is a frequency distribution, and there's only one answer. Is that right? We also have this whole concept of classes. Remember that? Like how many in this class? How many in this class? So we have this little range. So let's do that one and we'll finish up the day with that. Da, 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 da. Just want to make sure. Okay, we're good? Brian and Jacqueline, you guys good? Just want to make sure. Yeah, Jacqueline, you okay? Just want to make sure you know where things are coming from. That's what I'm super duper wanting you to know. We good? Okay. Okay. Da, da, da. I'm gonna jump through this. Yeah. Okay. 1.7. Hey, if you did 1.7, you're in the ballpark. Yeah. Okay, let's go with it. So we have another way of doing frequencies. Frequencies where there's like a spread in the data. So how much money spent on personal travel each year by people? It's not going to be $1, $2, $3, right? There's going to be now from $100 to $200, and there's a little spread in the middle. So now our data is crazy. So this is, whenever it says in the blue, adapted from the Travel Industry Association of America, dun, da, 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 that means it's usually data. I'm not sure what year it is, but it's usually data. Okay, here's what we got. We have anywhere from $100 to $199, 230 people, or couples or whatever, personal travel, so it's per person. $200 to $300 and $299 is 210 people. And then we go here, here, here. Oh, sorry, less than 100 right here, 380 people. And then $500 or more. It just caps off at 500. Okay, let's do this here. Let's see, time left. Let me give you guys the answers for the beginning, and we'll fill up the last ones here. So here it is. First things first, using a frequency distribution to organize the data, because the class of 500 or more is open-ended. You must choose a value anyways to represent that. So first things first. We're gonna make a table in just a second here. So, but first things first, let me see, less than $100, right? So if I'm gonna make these little tables, right, it's gonna be, so less than $100, can I make that into $99? Is that okay? Looks like we're rounding off to the nearest dollar. That's kind of what we're doing for our gaps. Okay, cool, we got that in place. And then the other one is plus 500. Well, if they spent $1 million, I still need a midpoint for that thing, right? And so even though it may be off, because I didn't get all the categories, I have to choose a midpoint. I don't know what the midpoint is because I don't know how much they spent. I just know they spent more than 500. So to keep the classes at least the same length, right? We're going to assume where the range is going to be 500 to $599. We're good. We're going to assume that. Okay, so let's jam. So thinking we won't have enough time to finish here. Let's just do as much as we can, and then I'll let you guys fill it in. We're good. So let's go with class. Class is coming down here, coming across. So the class is from $0 to $99. That's one. $100 to $199. Class 2, $200 to $299. $300 to $399. $400 to $499, and then I'm going to call this 400 and just call it plus, because I want to at least know the range that I have there. This is a range. That's not so fun, because now I need this little extra column called the midpoint. What's the exact middle of my range of $0 and $99? Again, 44, yeah. 49.5. Everybody okay there? $49.50 will be the exact middle of 99. Will be the exact middle of from 0 to 99. What's the exact middle from 100 to 199? Again. All right, and then remember, all the way from chapter 2, all we have to do is we add the range each time, don't we? So now can we do the rest of it without having to calculate with our calculator? Yeah, 249.5, 349.5, 449.5 and 549.5. Now, here's a little problem. Guys, real quick here, let's talk about this here. Not so fun in statistics because we got this 500 category. So you guys ready for this? Craziness. This guy here, because our category does not stop, you get to choose what number you want for that category for the midpoint. Your choice, you get to choose it yourself. Have fun, enjoy. So if you want to choose 459.9, at this point, because you did the survey, you should kind of have a feel for what that midpoint is, right? If you had a few people say $10,000, so then like, you know, I probably want to put that at like $600, right? Because I want to capture the midpoint there. So the book here, the book does 599.5. They add an extra $50 in here. So that's the way. Again, is it the correct answer? No, it is not. That's the one they chose to use. That's it. Okay, 5 more minutes left. Let's at least get to the sample mean, and then we'll show what the other categories are. So again, this is a class distribution, right? This is because we have a range in our classes itself. Let's jam. Now the frequency happens. Frequency from the table. I'm gonna go back over here. Where are we at? From this little graphic here. So I got 390 or 380, 230, 210, 50, 60, and then 70. Yep, I can memorize those numbers, no problem. It was 380, 230, I believe. 210, 50, 60, and then 70. Or I had it written down on my PowerPoint slide. Not that good. Okay. Summation would be 1,000. And again, let's go kind of quickly here. We have 4 minutes left here, so I'm going to go kind of quickly through the paces. We good? And let's do, I'll let you guys fill it in, and let's do the rest of it this way. Okay, so I got frequency, perfect. I need X times frequency because I need my mean. Oh, look at that. I'm adding the frequency up, and I'm adding the frequency. Oh, now this is the midpoint. So I got my frequency and midpoint. And I got 18,810, 34,385, 52,395, 17,475, 26,970, 41,965. And grand total is nice grand total 192,000 exactly. I love it when things work out nice. Let's see, sample or population, which one is it? Sample, it's the number of people that just took vacation. So X bar is going to be the summation of X of F divided by N. $192,000 divided by 1,000 people gets me $192. All right, so question to you guys, is that normal vacation time for you guys? Personal travel each year, that's what it was. Yeah, so you go on vacation by yourself, is that about $192?
Not like including like gas prices.
Yeah, now the question is this, now the definition, right? What's included in this price? Was it a hotel? Was the taxes of the hotel or not? And does it include gas to get there? Does it include extra things you did like souvenir buying, or does it include just necessities for vacation? Okay, guys, we're almost out of time here. Let me do this here. I will send you guys the answer to this. We're good. But let me put in the categories for you guys real quick. Let's put in the categories with a minute left. So the next column would be x minus x bar. Then it'd be x minus x bar squared. Then it would be x minus x bar squared times the frequency again. Say again. Okay. And this one here, the end I got is 25,668,750. That's overall for everything. So if we were to take that number, divide it by 1,000 or 999. 25,668,750 divide by, guys, 1,000 or 999. Sample population. Sample. Okay, -1 from it. Okay, approximately 160.3 or $160.30 is a standard deviation. Okay, stop. We still have not finished up 2.4. We have one itsy bitsy something called the coefficient of variation. We'll finish that up very quickly. We'll jump 2.5. I have confidence the next time we are going to finish up all that in the first hour. The second hour will be for homework questions, and then we take the test after that. We good? So the test has been extended one more day. Okay, eventually we'll get to the test. Okay, guys, have a great day. Today's Thursday. Have a great weekend and see you guys on Tuesday. Yep.